Okay, question 2. The number of heaters H bought one day from warm-up supermarket can be modeled by Poisson distribution with the mean 0.7. So, part A. H is distributed Poisson 0.7. We want to calculate the probability that H is bigger than or equal to 2, which is equal to 1. Take away the probability that H is less than or equal to 1, which is, using our calculator, menu 7. Poisson CD, variable x is equal to 1, lambda is 0.7, 1 take away 0.8441 is equal to menu 1 take away answer 0.1558. Okay, part B. The number of heaters G bought from the supermarket can model by Poisson with mean 3, which is nature independent. So G is distributed Poisson 3. Show that the probability that fewer than 4 heaters are bought from the 2 supermarkets is that. So let's say Y is equal to H plus G. Therefore, since they're independent, Y is distributed Poisson 3.7. The probability that fewer than 4 heaters are bought, so Y is less than 4, is equal to the probability that Y is less than or equal to 3, which is equal to, at that point it becomes just a type in the calculator question, and since its answer given, we know it's 0.494, but you probably would want to check in the exam to be sure you got the sum right. There's a little more we can write down there. We need to see that written down to show that you're doing the right sum. If Y is less than or equal to 3 isn't written down, then it doesn't get the A1 at the end. The method marks for that bit is the A mark, that bit there. Calculate the probability that fewer than 4 heaters are bought from these 2 stores on 5 or 6 randomly chosen days. At least 5 or 6 randomly chosen days. So now we've got 6 days, and the probability of buying 4 heaters or more is that on each day. That fulfills our criteria of being binomial again. So we'll call this, what should we call it now? I'll go with K, since the mark scheme uses K. Is there a good reason for K? Who knows? That's that. K is distributed binomially. Does 6 days, 0.494 is the probability that more than 4 or fewer are bought on that day. We want to know whether it happens on 5 or more days, which again is 1 take away the probability that K is less than or equal to 4. 1 take away. That we can work out on our calculator, menu 7. Binomial CD. Variable. Four, 6, 0.494, 0.896. Which is 0.1039. And finally, part D, December was particularly cold. 2 days in December were selected at random, and the number of heaters bought were found to be 14. Test whether or whether not the number of heaters bought from these 2 supermarkets has increased at the 5% level. So, firstly, state our hypotheses. Our hypotheses are that nothing's changed. So our null hypothesis is that lambda is still 3.7. Alternative hypothesis, however, is that actually we're selling more heaters because it's chilly, so lambda is bigger than 3.7. Now it's over 2 days. Remember that lambda's a rate. That's 3.7 on 1 day, but we're looking at 2 days in December. So actually, if H0 is true, assuming H0 is true, then J is distributed to Poisson 7.4. Now you've got two choices there how we do this. We either work out the probability or we find the critical value. It doesn't matter which you do, but you just have to make sure there's some probabilities thrown away in there. So we'll do the critical value method. So we want to find the probability that J is, we want to find what the critical value is that would surprise us. We're testing at the 5% level, so we want that tail to be less than 5%. Our calculator can't do that, so that's one take away. The probability that J is less than C minus 1 is less than 0.05. So the probability that J is less than or equal to C minus 1 must be bigger than 0.95. It pays to do some sort of guesswork now where the answer might be. Menu 7, press on CD, list. So we'll start, we know we're looking at 14, so we'll do 10, 11, 12, 13, 14, 15, 16, 17, 18. Lambda's 7.4. We want the first number that's bigger than 0.95, which is 12. So we see it's 12. Now we do have to write a probability down. No probabilities means no marks. So the probability that J is less than or equal to 12 is 0.9608. The probability that J is less than or equal to 11 is equal to 0.9264. So therefore the probability that J is bigger than or equal to 12 is 0.0735, and the probability that J is bigger than or equal to 13 is 0.0391. These probabilities need to be there to get the marks, basically. If you don't write them down, even though you've done the right thing and correctly found that the critical value is 13, and correctly therefore said that the critical region is going to be J bigger than or equal to 13, without those probabilities it's all for naught. Then we look and we see that the number that was 14, so 14 is in the critical region. Therefore reject H0. There is some evidence to suggest that the number of heaters has increased. Remembering again to give your answer in context. If there's one thing I'm going to stress, and I'm going to stress it again because I want to, even though you've stopped watching the video already, it is that these probabilities are key to getting the marks. You have to show these in all hypothesis tests, the actual probabilities, not just doing your calculator.